Network Address Translation, or simply NAT. In computer networking, Network Address Translation, or NAT, is the process of modifying IP address information in IP packet headers while in transit across a traffic routing device. The simplest type of NAT provides one-to-one translation of IP addresses. RFC 2663 refers to the type of NAT as basic NAT, which is often also called a one-to-one NAT. In this type of NAT, only the IP addresses, IP header checksum, and any higher level checksum that include the IP addresses are changed. The rest of the packet is left untouched. It means, at least for basic TCP/UDP functionality. Some higher level protocols may need further translation. Basic NATs can be used to interconnect two IP networks that have incompatible addressing. However, it is common to hide an entire IP address space, usually consisting of private IP addresses, behind a single IP address. To avoid ambiguity in this handling of returned packets, one-to-many NAT must alter higher level information such as TCP/UDP ports in outgoing communications and must maintain a translation table so that return packets can be correctly translated back. RFC 2663 uses a term NAPT, or Network Address and Port Translation, for this type of NAT. Other names include PAT, or Port Address Translation, IP masquerading, NAT overload, and many-to-one NAT. Since this is the most common type of NAT, it is often referred to simply as NAT. As described, the method enables communication through the router only when the conversation originates in the masqueraded network, since this establishes the translation tables. For example, a web browser in this masqueraded network can browse a website outside, but a web browser outside could not browse the website in the masqueraded network. However, most NAT devices, servers, or other equipment today allow the network administrator to configure translation table entries for permanent use. These features is often referred to as static NAT or port forwarding, and allows traffic originating in the outside network to reach designated hosts in the masqueraded network. In the mid-90s, NAT became a popular tool for alleviating the consequences of IPv4 address exhaustion. It has become a common, indispensable feature in routers for home and small office internet connections. Most systems using NAT do so in order to enable multiple hosts on a private network to access the internet using a single public IP addresses. Of course, as you can saw in previous lessons, IP addresses is limited, although there are a lot of IP addresses in Class A, Class B and Class C overall, but the number of IP addresses are limited. That's why it is recommended for small ISPs, Internet Service Providers, or home users, or when it is not required to use the real static IP addresses, instead of real IP address, do the NAT on the router or a server and serve the real IP addresses. Network addresses translation has serious drawback in terms of the quality of internet connectivity and requires careful attention to the details of its implementation. In particular, all types of NAT break the originally envisioned model of IP end-to-end connectivity across the Internet, and NATP makes it difficult for systems behind the NAT to accept incoming communications. As a result, NAT traversal methods have been devised to alleviate the issues encountered. The majority of NATs map multiple private hosts to one publicly exposed IP address. In a typical configuration, as you can see on your screen, a local network uses one of the designated private IP addresses, subnets. A router on that network has a private address in that address space. The router is also connected to the Internet with a public address assigned by the Internet Service Provider. When we are talking about the router, the functionality of the router can do the small server, of course, if the network is small, not big. It's a small office or home network. In this case, as you can see, the regular computer do the functions of NAT, also the routing. That's why you can see that the packets goes to another computer, from one computer to another computer, and the special software which can do a NAT and routing routes the IP packets, encapsulates and routes to the main router, through which it can reach the Internet. All Internet packets have a source IP address and a destination IP address. Typically, packets passing from the private network to the public network will have their source address modified, while packets passing from the public network back to the private network will have their destination address modified. More complex configurations are also possible, but we will not talk about this. As the traffic passes from the local network to Internet, the source address in each packet is translated on the fly from the private address to the public address. Translated. That's why we call network address translation. The router tracks, or server of course, tracks basic data about each active connection, particularly the destination address and port. When a reply returns to the router, It uses the connection tracking data it stored during the outbound phase to determine the private address on the internal network to which to forward the reply. To avoid ambiguity in how to translate returned packets, further modifications to the packets are required. The vast bulk of Internet traffic is TCP and UDP packets, and for these protocols, the port numbers are changed so that the combination of IP and port information on the returned packet can be unambiguously mapped on the corresponding private address and port information. Protocols which are not based on TCP or UDP require other translation techniques. ICMP packets typically relate to an existing connection and need to be mapped using the same IP and port mapping as that connection.